Curve C has equation y equals 7 plus 13x minus 2x squared. The point P lies on C and is such that the tangent to C at P has equation y equals x plus c, where c is a constant. Find the coordinates of P and the value of C. So let's go back to the question. It did say the tangent to C at P has equation y equals x plus c. Now let's remind ourselves what we mean by tangent. So if I just draw a sketch of any curve, and let's just say that this red dot here is P, say, then a tangent to the curve at P would be a straight line that touches the curve at that particular point. So a tangent is always a straight line. So we also need to remember then what we know about straight line equations. Now a straight line equation can always be written in the form y equals mx plus c, where m would represent the gradient of the line and c would represent the y-intercept. Now if we have a look at the question again, we were given the equation of the tangent, y equals x plus c. Now that is of the right format, that is of the form y equals mx plus c. Therefore we can see that the gradient must be 1, as 1 is the coefficient of x. We also need to remember that to work out the gradient of the tangent, we can differentiate the curve. That would generate a formula for the gradient of the curve at any point. Now, we've given the equation of the curve. We know it's y equals 7 plus 13x minus 2x squared. Before we look at differentiating that, let's just remind ourselves how to differentiate. So if you have y is equal to x to the power of n, say, then remember to differentiate, you bring the power to the front, so the n would come to the front, and you would decrease the power by 1, so the differentiation of x to the power of n would be nx to the power of n minus 1. So let's go back to the question. The differentiation of 7 would be 0. The differentiation of 13x, the power 1 would come to the front, so it would become 1 times 13, and we would decrease the power by 1, so the power would become 0. The last term then, the 2 would come to the front, so it would become minus 2 times 2, and we would decrease the power by 1, so it would become 1. 1 times 13 is 13, and x to the power of 0 is 1. So we're left with 13 as the first term, and then the second term, 2 times 2, is equal to 4. So we have minus 4x as the second term. So that now is a formula for the gradient of the tangent at any point on the curve. Now we don't need any points, we need one particular point. And that is when the gradient is equal to 1. So if 13 minus 4x is the formula for gradient, and we know the gradient is equal to 1, then I can now write down that 13 minus 4x is equal to 1. So what I have there is an equation that I can now solve. If I subtract 13 from both sides, that would leave us with minus 4x on the left side, and 1 minus 13 is minus 12. If we divide both sides by minus 4, that would leave us with x on the left side, and minus 12 divided by minus 4 is equal to 3. So I know that x is equal to 3 when the gradient is equal to 1. If we have a look at the equation of the curve, we did in fact have a formula to work out the value of y. When x is equal to 3, we can work out y by substituting 3 into the equation. So 7 plus 13 times 3 minus 2 times 3 squared, which is 28. So what we now know is that P must be 328. It did also ask us to find the coordinates of P and the value of C. So what we know is that when x is equal to 3, y is equal to 28. So if I substitute those values into the equation of the tangent, I would get 28 is equal to 3 plus c. This allows us to work out the value of c. I can subtract 3 from both sides, and then I can see that c must be 25. Now, that particular exam question focused on equation of a tangent. Be aware that you also need to know how to work out the equation of a normal. So let's look at an example that looks at both. So in this particular example, the question's asking us to find the equation of the tangent and normal to the curve y equals 4x squared minus 7x plus 2 at the point 2, 4. Now, if you have a curve, just remind ourselves first of all that a tangent to a curve would be a straight line that touches the curve at a particular point. So in this case, I've noted a red point on the curve. So a tangent is always a straight line. Now, the normal to the curve is always perpendicular to the tangent. So remember, perpendicular lines would meet at a 90-degree angle. So the normal is also a straight line. So what we are going to do first of all, if we want to work out the gradients of either the tangent or the normal, what we're going to do is we're going to differentiate, because differentiation will give you a formula for the gradient of the curve at any point. So the differentiation of 4x squared would be 8x, and the differentiation of minus 7x would be minus 7, and the differentiation of plus 2 would be 0. So the differentiation is 8x minus 7. Now that means that 8x minus 7 is the formula for the gradients of the curve at any point. Now, the gradient of the curve is the same as saying the gradient of the tangent. So what I now have is a formula for the gradient of the tangent. Now, I don't want the gradient of the tangent at any point. This question is saying at the point 2, 4. So when x is equal to 2. So if I substitute x equals to 2 into the differentiation, I would get 8 times 2 minus 7, which gives me 9. So what I know is the gradient of the curve is 9 when x is equal to 2. So this means the gradient of the tangent is equal to 9 when x is equal to 2. Now, if the gradient of the tangent is equal to 9, remember that the product of gradients of perpendicular lines is always minus 1. Therefore, if the gradient of the tangent is 9, then the gradient of the normal must be minus the reciprocal of 9, so minus 1 over 9. And you can check if this makes sense, because if you do 9 multiplied by minus 1 over 9, it should give you minus 1 as an answer, and it does. So what we have is the gradient of the tangent, and we now have the gradient of the normal. Now remember, a straight line equation can be written in the form y minus the y ordinate of the particular point in question equals the gradient m x minus the x ordinate. Therefore, if we're looking at the point 2, 4 and we know the gradient is 9, what I can now do is substitute these values into the general format of a straight line equation. So I can now write down y minus 4 equals the gradient, so 9, and then brackets x minus 2. And if we expand the brackets, that would leave us with y minus 4 equals 9x minus 18. And what I'm now going to do is get everything on one side. So I'm going to rearrange the equation by subtracting 9x from both sides and adding 18. And that would simplify the equation to be y minus 9x plus 14 is equal to 0. If we look at the normal again, we now have the gradient as minus 1 over 9. The points are still the same points. It's still 2, 4. Therefore, the only difference is going to be the gradient. So we have y minus 4 is equal to minus 1 over 9, and in the brackets, x minus 2. Now, you don't have to do the next step, but you will probably find that it's easier if you do, and sometimes, depending on the formats that's been asked for you to write the equation in the question, you might have to. So what I'm now going to do is actually get rid of the fraction. I don't want the 1 over 9 in the question. I want to get rid of the fraction. So what I'm going to do is I'm going to multiply the whole equation through by 9. And that would leave me with 9y minus 36 on the left side. And if I multiply the right side by 9, then what happens? It just cancels with the 9 in the fraction. So we're left with minus 1 multiplied by x minus 2. And if I multiply out the brackets, it leaves me with 9y minus 36 is equal to minus x plus 2. And again, if we rearrange the equation to get everything on one side, it would leave me with 9y plus x minus 38 is equal to 0. So we have the equation of the tangent and we also have the equation of the normal. So remember, if you ever have to work out the equation of the normal, you can differentiate the curve to get a formula for the gradients of the tangent. So remember, that is not the gradient of the normal, that is the gradient of the tangent. However, there is a connection because we know the normal is always perpendicular to the tangent.